So in section 7.3, we're working with equations that involve fractions and decimals. A higher level way of solving an equation like this is actually remove the fractions out of the problem. So when we have complicated equations like this, we can manipulate it in a way that we really won't have to necessarily use calculators. You're more than welcome to use calculators, but if you want to use some of your math skills, you can kind of manipulate this problem where you can kind of solve this problem just using paper and pencil. So the strategies in solving equations to this level, the following steps can be used. So again, we want to simplify each side of the equation by removing parentheses. Distributive property is what we're talking about there, and combining like terms. So if we look at this equation, I don't see any parentheses on either side, and 2/7 y and this 2/9 are not like terms because this has a y in it. So the 2/7 is a coefficient. The y is the variable here. So that's one term. And 2/9 is called a constant because it does not have a variable. So these two terms are not considered combinable. And on the same thing on this right-hand side, the 1/7 y and the 5/3 are not like terms. But if fractions are present, what we can do is multiply by what's called the least common multiple, or basically we're trying to get rid of the denominators in this problem. So this may require us using some parentheses and the distributive property to do this. So also, if the variable is in the denominator, exclude any number that makes the denominator equal to 0. To do this, we set the denominator equal to 0 and solve. There can be more than one exclusion. So notice how it says identify any excluded values. That only happens if the variable is in the denominator. Well, the denominators are actually numbers, the 7, the 9, and the 3. So we do not have to worry about any excluded values. There aren't any. Because one of the things we're not allowed to do in math is division by 0 is not possible. So again, just a reminder, if I have, say, 10, let's see if we can get this to work for us here. So remember, if I have 10 divided by 2, we know that is equal to 5 because 5 times 2 does equal 10. Now, if I have 10 divided by 0, what does that equal? Well, the question is what times 0 gets me back to 10? And you can't multiply a number by 0 and get 10 because when you multiply by 0, the answer is always 0. That's the multiplication property of 0. So 10 divided by 0 is not workable because I can't get an answer. There's no number that you can, if you go the other direction, you cannot multiply a number by 0 and get back to 10. And also you can think of it another way, you're starting with 10 and you're dividing it into 0 groups, because remember the bottom number is how you're grouping it. So like if I have 10 divided by 2, 10 divided by 2 means to create 10 objects. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 divided by 2 means you have 10 objects and you group them by twos. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. The answer is how many groups are present. Well, 10 divided by 0 means you're dividing into 0 groups. Well, that doesn't even make any sense. So division by 0, again, kind of falls apart. So in fraction thinking and in division thinking, we have to exclude numbers that make the denominator equal to 0. So if the denominator is a variable, we have to exclude a number that makes that variable, makes that denominator turn into a 0. So that's one of the things we have to pick up on here. But we're in good shape here because the variable is not in the denominator. So that's some of the things we have to pay attention to here to start with. So in this example, there aren't any excluded values because the variable is not in the denominator. So as we move forward in this problem, let's see if we can write this down. So we have 2/7 y plus 2/9, and that's equal to 1/7 y plus 5/3. One of the higher level strategies in equations is you can multiply both sides of the equation, but if I can multiply by a number that can make the fractions uh, drop out of the problem, it makes it a lot easier to do this problem mentally. So if we look at the denominators, what I'm seeing, there's a 7, there's a 9, and there's a 3. So if I can find a common denominator between a 7, a 9, and a 3, that's going to help us manipulate this problem. So if you think of multiples, the multiples of 7 would be 7, 14, 21, 28, 35. The multiples of 9 are like, maybe what, 9, 18, 27, was that 36, 45. So I'm not seeing anything in common, so I have to continue on there. So we have, what is that? 42, 49. What's another one there? 7 times 8 would be what? 56. Continue here. We have what? 54. Still nothing. So 7 times 8 was 56. 7 times 9 is 63. This would also be 63. So I noticed that, you know, 3 is going to fall in line with the 9s because, you're going to have 3, 6, 9. So notice that about every third multiple of 3 is going to be a multiple of 9. 12, 15, 18. So what we got to figure out is, well, how many 3s does it take to make 63? So that's not too bad of long division. So if I do 3 into 63, how many 3s would that take? So 3 goes in 6 twice, 3 goes into 3 one time. So it would be 21 3s. So yeah, so 63 would be out here, but I would have to write down 21 3. I have to write down 21 factors there, if you will, to get to that spot. We don't need to do all that. So what we're picking up on is 63 is going to be a very powerful number for us because if I multiply both sides of the equation by 63, that's going to allow us to eliminate fractions. So by using parentheses, I can kind of do this. I can multiply 63 and I can kind of make a set of parentheses here. I'll go ahead and make a set of parentheses over here so I can go back to my other color. So we have this 2/7 y plus this 2/9. And over here we have this 63 with this 1/7 y plus this 5/3. So if you're able to identify that common multiple rather easily, this makes this problem pretty manageable. So it really depends on how good your multiplication division skills are. So notice how we're going to now use the distributive property. When we distribute through here, we're going to multiply 63 times this coefficient, 63 times 2/7. But remember, when you multiply by fractions, you actually can divide first. So notice that 7 goes into 63. That's going to turn it into a 9 because notice how it took 9 sevens to get 63. So 7 goes in 63 9 times, and then 9 times 2 is going to be this 18, and then 18y would drop into the problem. And then when you bring across here 63 times 2 ninths, if you will. Notice the 9 goes into 63 as 7, and then 7 times 2 would be 14. So you have then plus this 14. So as we move to the other side of the equation, again, I want to distribute the 63 through the parentheses. So we have to multiply the 63 to each of these two terms here. Now, what happens here, though, is really what we want to do is divide out this fraction. So 7 goes into 63. That's going to be a 9, and then the 9 is going to go through the parentheses. 9 times 1 is just going to be 9. So it just turns into a 9y. And then 63, when we multiply by 5/3, notice that 3 does go into 63. We kind of did that math over here. That's going to be a 21. And then 21 times 5. That math is not too bad. 21 times 5. So we have a 5 and a 10. So it'd be 105. So plus 10, 105 would be there. So notice how this problem now is a problem that does not have fractions in it. So now we can kind of move up here and see that we're now through the simplifying part. There weren't any decimals present. So if the variable's on both sides, we pick on the little guy using what I call the serial pair. So notice how the 18y and the 9y, notice how the variable is on both sides. I consider 9y littler because its coefficient is littler. So what I can do is zero out the 9y by using a negative 9y, but I have to use the property of equality here and put a negative 9y on the other side of the equation, like so. So what happens from here is we then have 18y, and we're going to lose a 9y, so it's going to be a 9y plus this 14 is equal to 105. And then now we're getting closer. So now we're just trying to get x by itself. So we use the zero pair for the constant. So again, we're trying to get the y by itself. The 9 is called the coefficient. The 14 is called the constant. So we want to lose the 14. So to zero out of 14, its opposite is a negative 14. So we put a negative 14 here, a negative 14 there. So then if we do that math, we have the 9y comes down. These will zero out, and 105 lose 14. So 105 lose 14. So we have 5 minus 4 is 1. We can't do that math, so we can borrow. This turns into 0. This turns into a 10. 10 minus 1 is 91. Does 91 plus 14 give me 105? Yeah, 91 plus 14 does give me 105, so just kind of check out there. So this would be turning into a 91. So then to solve this problem, we have to divide both sides by 9. So I'm going to come over here and write 9y equals this 91. To get the coefficient, again, up here, notice how we want to use division to make the coefficient equal to 1. So if we divide by the coefficient turns into a 1. So now we have 91 divided by 9. And that's where we may want to use a calculator. I don't have mine available at this point, so I'm going to choose long division. So 9 goes into 91. Don't look like it's going to go evenly. So 9 goes into 9 one time. Get a remainder of 0 there, so 1 goes down. So 9 doesn't go to 1, so I'll use 0 as a placeholder, so that's going to be like 10 and 1/9. So 10 and 1/9 would be our answer. So we believe the answer is 10 and 1/9, but again, in my lab, we have to figure out what they want. So it looks like 9 and 1/9 is not reducible. There's not a common factor in 9 and 1/9. So our answer is going to stay as 9 and 1/9 or 10 and 1/9, depending on what my lab allows us to do. And again, you could type 10 91/9 into the calculator and see for sure if it reduces or not. Yeah, I don't see that happening because 3 will not go in 91 either. How do I know that? One of the shortcuts is if you add the digits together, 9 plus 1 is 10. If 3 went into 10 evenly, then that tells me that 91 is divisible by 3. But since 3 did not go into that sum, so since 3 did not go into that sum of 10, this tells me that 3 is not, 91 is not divisible by 3. So we're left with that 91 ninths, or again, 10 and 1 ninths, depending on how MATLAB wants us to work that out. So again, this is a lengthy problem regardless of how you do it. And again, if you just want to use the calculator, you can treat this just like we did in the last section.